Hello dear student, myself Prof. Sabburejke. Today we learn new chapter Thermodynamics. In this chapter we can discuss some important concept. First one is thermal equilibrium, next one zeroth law of thermodynamics, next heat, internal energy and work. Then we can discuss next point first law of thermodynamics, another one thermodynamic state variable, and next one thermodynamic process heat engine, next one refrigerators and heat pumps, next point second law of thermodynamics, and last one Carnot cycle and Carnot engine. These all topic we can discuss one by one. Firstly, we can discuss introductory part in the chapter. The thermodynamics is the study of convention of work or any form of energy into heat and the other way rounds. It is an important branch of physics having many practical applications. According to modern theory, heat is a form of energy. When hot object is a contact with cold water, the hot objects gets cooler and cold object become warmer, and both objects reach the same temperature after some time due to exchange of heat. Then we can discuss actual definition of a thermodynamics. Actual definition of a thermodynamics. Definition: thermodynamics is the branch of physics that deal with the concept of heat and temperature and the interconvention of a heat and other form of a energy. Repeat again this definition: thermodynamics is the branch of physics that deals with the concept of heat and temperature and the interconvention of heat and other form of a energy. Then we can discuss another definition. What do you mean by thermal equilibrium? When two systems are said to be in a thermal equilibrium. When do two systems are said to be thermal equilibrium? Definition of a thermal equilibrium: this two system is a thermal contact. Two system is a thermal contact with each other are said to be thermal equilibrium if they do not transfer heat between each other. When two objects are at same temperature, they are in thermal equilibrium. What I mean by thermal equilibrium? Two systems is thermal contact with each other are said to be thermal equilibrium if they do not transfer heat between each other. For example, when two objects are at a same temperature, they are in a thermal equilibrium. If temperature of two objects is same, then we can say these two objects or they are in a thermal equilibrium. Then important point in this chapter, zeroth law of thermodynamics. Zeroth law of thermodynamics. Statement here. If two systems are each in a thermal equilibrium, with a third system, they are also in a thermal equilibrium with each other. Statement of zeroth law of thermodynamics: if two systems are each in a thermal equilibrium with a third system, they are also in a thermal equilibrium with each other. This is a statement of zeroth law of a thermodynamic. For example, we can explain the zeroth law of thermodynamics. See this diagram, schematic representation of zeroth law of thermodynamics. zeroth law of thermodynamics. See this figure. Figure show that schematical representation of zeroth law of thermodynamics. The double arrow represented here. This double arrow represented here. Thermal equilibrium between system. If system A and C, suppose consider system A and C are in thermal equilibrium, and then system A and system B are in a thermal equilibrium, then the system B and system C must be thermal equilibrium. The system B and system C must be thermal equilibrium. Then it can be inferred that system ABC are at a same temperature. This is a zeroth law of thermodynamics. Some question asked on this topic: state zeroth law of thermodynamics, and another one, explain zeroth law of thermodynamics using a schematic representation. Okay, and then we will discuss significance of a zeroth law of thermodynamics. Significance of a zeroth law of thermodynamics. First significance, to use a thermometer to compare the temperature of a different objects. To use a thermometer to compare the temperature of a different object. We can compare temperature of a different objects. We use thermometer. This is a first significance of a zeroth law of thermodynamics. Next one, second, when we use thermometer, the thermometer and the objects are equilibrium, and thermometer indicates the temperature of the objects. This thermometer we can use here. Thermometers and the objects are equilibrium, and thermometers indicates the temperature of these objects. And third significance, temperature is defined on the basis of zeroth law of thermodynamics. This is a significance of a zeroth law of a thermodynamics. Some question asked on this topic: what is the significance of zeroth law of thermodynamics? We can discuss these three significance of a thermodynamics. The temperature can be defined as per zeroth law of thermodynamics as follow. The physical quantity that determine whether or not a given system in a thermal equilibrium with another system. The temperature can be defined as per zeroth law of thermodynamics. The physical quantity that determine whether or not a given system is in thermal equilibrium with another system. And next point, what is mean by thermometry? What do you mean by thermometry? The science of measuring temperature is called as a thermometry. The science of measuring temperature is called as thermometry. Then we can discuss next point is a thermodynamic system and a thermodynamic process. Thermodynamic system and thermodynamic process. Thermodynamic system is a collection or a group of objects that can be formed a unit which may have ability to exchange energy with its surrounding. See this diagram. See this diagram. We can see here, here a system. Next, we can discuss another concept is a surrounding. This surrounding is called as environments, and another concept is a boundary. Firstly, we can discuss surrounding or environments. Definition: anything that is not part of a system, anything that not part of a system is called as a surrounding or environments. Surrounding or environments. Another definition: what do you mean by boundary? The surface, the surface, the surface in which separating the system from the surrounding. This is separate system, and surrounding is called as a boundary. And next, for example, water kept in vessel is a system. The vessel is a boundary, and atmosphere around the vessel, it is called as a surrounding. Then we can discuss another points: classification of thermodynamic system. Classification of a thermodynamic system. Thermodynamic system can be classified as open, closed, and isolated system on the basis of possible transfer of heat and matter to the environments. First one, we can discuss an open system. An open system. An open system is a system that freely allow exchange of energy and matters. Exchange of energy and matter with its surrounding. Or if it's a definition of a open system, an open system is a system that freely allow exchange of energy and matter with its surrounding or environments. For example, water boiling in a kettles. Here heat or energy and matter exchange, freely exchange with its environments and surrounding. This is called as a open system. See this diagram. Both heats and matters exchange in open system. And next system, consider here closed system. Definition: second system, closed system. A closed system does not allow the exchange of matter, but allow energy to be transferred. For example, water boiling in a boilers. Closed system. Here a closed system does not allow the exchange of matter, but allow energy to transfer. Here energy, here matter does not exchange, but allow energy to be transferred or heat to be transferred in a closed system. See this diagram. And third type is a isolated system. What do you mean by isolated system? An isolated system is completely sealed. An isolated system is completely sealed. Isolated from environments means isolated from environments. Matter as well as heat cannot be exchanged with environment. This system is called as a isolated system. For example, water kept in a thermos flask. This is a diagram of a isolated system. Diagram of a isolated system. Okay. Then we can discuss here first open system, then next we can discuss closed system, and third system is an isolated system. Question asked on this topic: what is a thermodynamic system? How are the system classified on the basis of transfer of heat and matters? Question repeats here. What is a thermodynamic system? How are the system classified on the basis of transfer of heat and matters? Then we can discuss next point here. Next point here. The flow of energy between the system and its environments with the help of neat diagram for the following condition. The flow of energy between the system and its environments with the help of its diagram for the following condition. Here we consider uh, Ts be the temperature of the system. Next one, T suffix E be the temperature of the environments or surroundings, and Q be the energy transfer between the system and environments. Condition first here. Condition first here. When the transfer of the system, when the temperature of the system is less than that of environments, we can write this, that is Ts less than T suffix E, the energy flow into the system as shown in the following figure. Suppose a system here, system, the temperature of this system consider Ts, and T suffix E here, temperature of the environments, and Q here, Q is greater than 0. Q is greater than 0. As a result, the temperature gain energy and Q is a positive. Here first condition, as result the system gain energy, and here Q is a positive. Next one, second condition. Second condition, when Ts, that is a temperature of the system, is greater than temperature of the environments, that system losses energy, that is the energy flow from the system into the environment as shown in this figure. Here a system, T suffix S be the temperature of the system, and here T suffix E be the temperature of the environments. Then Q, here Q less than 0 means what? Here here in this case Q is a negative. In this case Q is a negative. Here Q is negative. And third condition we can see here, for Ts is equal to T suffix Ts is equal to T suffix E means what? Temperature of the system is equal to the temperature of environment. The system and environments are in the thermal equilibrium as shown this figure. Then a result, in this case there is no transfer of energy, then we can write Q is equal to 0. Q is equal to 0. From this condition we can discuss what I mean by heat. Definition prepare here. Heat is a energy that is transferred due to temperature difference that exists between the two. Heat is the energy that is a transfer due to temperature difference that exists between the two. This heat is denoted by letters Q here. Letters Q. Here a question asked on this topic. Explain. Explain the flow of energy between the system and its environment with the help of neat diagram for the following condition. First is temperature of the system is less than that of the environments. Second condition, temperature of the system is more than that of environments. And third condition, both are in thermal equilibrium. If first temperature of the system is less than that of environments, then as a result system gain energy, that is Q is positive, and a temperature of the system more than that of environments, then in this case Q is a negative, and another both are in a thermal equilibrium, that is Ts is equal to T suffix C. Then here there is no transfer of heat, that is Q is equal to 0. And note, what is meant by heat? Heat is a energy that is transfer due to temperature difference that exists between the two. Then we can discuss uh, next point, what is meant by thermal energy of a system. What is meant by thermal energy of a system? Here, how can internal energy of a gas be changed by heating it? uh, Next one, we have seen that the internal energy of the system can be changed due to exchange with the environments. Now let us see how this transfer of energy between a system and its environment is possible. Consider the following experiment. See this figure. Small a shows the cylinder filled with some gas in it. This cylinder filled with movable, massless and frictionless piston. At one end, the gas inside the cylinder is our system and rest in environments. Let's Ts be the temperature of the gas, that is a system temperature of the system, and T suffix E, here T suffix E, the temperature of the environments, temperature of environment. The internal energy of the system can be changed into two different way. First, see this diagram. See this diagram. When cylinder is heated, then the heat is transferred toward the gas. Then heat is transferred toward the heat is transferred toward the gas. This is because T suffix E greater than T suffix E, that is a temperature of environments is greater than temperature of the system. Thus the internal energy of the gas increases. Such exchange is possible in another way if the surrounding is at lower temperature than the gas, that is a temperature of the system is greater than temperature of the environment, the gas will be lost energy to its environments and cool downs. This is a first condition. Then other way See this diagram other way. To increase the internal energy, to increase the internal energy of the gas is to quickly push the piston inside the cylinder so that the gas is compressed as shown this figure. In this case work is done. In this case work is done. The gas gain energy and its temperature is increased. On the other hand, if the gas pushes the piston out, some work is done by gas, it loses its energy and gas cool down. Thus, we see that the internal energy of a system can be changed into two ways. First is a first way is by heating it, and a second way by doing work on it. Both are related through the energy that is transferred to the system and the heat is involved in the process. This leads us to first law of thermodynamics. uh, Next next lecture we can discuss new topic, first law of a thermodynamics. Some question asked on this topic: how can internal energy of a gas can be changed by heating it. Today we stop here. Thank you.